Okay, now we're going to be talking about what are called imaginary numbers. Woo!
Woo!
Okay, so our lead into imaginary numbers is what all the other numbers you know are first. 1, 2, 3, yada, yada, yada. Those are all part of what are called the natural numbers. That doesn't look like a fancy natural number in, but it is. It starts with the number 1 and just keeps going and going and going. You could think of Roman numerals. Have you ever seen a Roman numeral 0?
Mm-hmm.
No, because they don't have a Roman numeral 0. Your whole numbers, which is a fancy W looking thing for whole, that sort of looks like it. Those have 0, 1, 2, 3, yada, yada, yada. So whole numbers are just like natural numbers, only they have a 0. So the easy way to remember that is when you spell whole, you put a 0 in the middle, okay? Let's see what comes after whole. Oh, Z. Now why Z stands for integer? I don't know, it's the integers, all right? So it's all your whole numbers and their opposites. Okay, opposites have the same absolute value, the opposite sign. So it would be like yada, 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 -3, -2, -1, 0, 1, 2, 3, yada, 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 everything that way. Those are all your integers, okay? Q stands for rational. The reason the Q is there is because of the word quotient, because when you divide, you get a quotient. All right, so your rationals would be all your, here's the formal definition, A, B, such that A and B are elements of the integers and B is not equal to 0. Okay, basically it's anything that can be written as a ratio of integers. Anything that can be written as a ratio of integers is a rational number. If you can write it like a fraction, decimal, or percent, it's rational. The only rule that doesn't work here is if B is 0. If you have 0 in the denominator, it's not rational because it's undefined. Okay?
Okay.
There's a number called an irrational number, and they just put the bar over the rational, which means not rational. Can you believe that? It's true. All right, irrational numbers, don't really have a big definition for them, but they're basically, they're non-repeating.
And not rational.
Non-repeating, yeah, they're not rational. They're non-repeating, non-terminating decimals. A good example of an irrational number would be pi. Never repeats, never ends. Square root of 2, square root of 3, square root of 5. The square root of any integer, that's not a perfect square. Okay?
Okay.
Square roots cannot be written as fractions, hence they're square roots. They're called irrational. All right? Real numbers, and you don't necessarily have to write all this down, but you guys are writing like crazy, so just feel free to keep writing. There's actually a section under number sets. I just wanted to give you an idea so you could figure out where imaginary numbers fit in the big picture. Real numbers are the union of rational numbers and irrational numbers. So every number that you know is a real number up to this point, until today.
Okay.
Every number that you used has been real. You can either write them as a fraction or you can't, but every number you use has been real. All right? Outside the realm of real numbers is where they came up with these things called imaginary numbers. And this is when we're going to start dividing things with a negative under the square root.
Okay.
Now, if you think about it, if you take the square root of something, like square root of 25 is 5, right?
Mm-hmm.
You can never end up with a negative number.
No.
Okay? Well, so how do you take the square root of a negative number? That's what they did. They came up with this thing called imaginary numbers to take care of that. Okay? These are not real numbers. They're imaginary. Okay, so these are the rules behind imaginary numbers. You're going to see a little I. A little I stands for the square root of -1. You need to memorize that. Okay? I square, it would be
Equals
square root of -1
1
times square root of -1.
Positive 1?
It would just be a -1.
Oh,
If you thought about it,
yeah.
because you got square root of -1 times square root of -1,
So
and square root times
of
square
-1
root,
squared.
it undoes itself, so you equal the -1.
Mhm.
Just hang with me, accept it. You don't have to like it, you just have to do it. Okay, I cubed. All right, that's going to be I times I square. Would you agree with that?
Mm-hmm.
Mm-hmm.
So that's going to be I, right, is the square root of -1 times I squared, which is negative 1, which is the negative square root of negative 1, or you could just say negative I. Okay, I is the square root of negative 1. When I multiply that times itself, I get negative 1, because the square root goes away. Just like when I have square root of 2 times square root of 2, what does that equal? 2.
Well, those are both.
It doesn't matter what's inside. Square root times square root
Oh,
of
okay.
the same exact thing pops out your same thing later. Okay, same thing here. So when I have I cubed, it's like negative 1 times this, so it's negative I, or negative square root of negative 1.
Yeah.
Okay, I to the 4th. Would be the same thing as I square times I square, which would be negative 1 times negative 1. So what do you get? 1.
Do we have to memorize those?
These are the 4 you need to know.
Okay.
Okay? This one, because it's the definition. This one, I squared, makes sense because we're going to be doing some squaring later, and you're going to want to be able to convert I squared to a negative 1. Okay?
Okay.
This one, because you're still going to be converting, and I to the 4th being 1 is a big deal. So those are big major ones. I'll tell you what they're doing later on down there on your notes, though. Okay? So these are the ones you really need to know.